In an earlier video, I talked to you about the three measures of variation: range, variance, and standard deviation. And I told you that the standard deviation was the best measure to use because it's the one that's interpretable. How do we do that, you wonder? Don't worry, I'll explain that in the next 6 minutes. Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hi, Mark here from 6 Minute Statistics, and before we talk about interpreting the standard deviation, I want to ask you a favor. Would you mind liking this video and subscribing to my YouTube channel? Thanks. Now, about that standard deviation. Interpreting it also involves working with the mean of the data set as well. Why? Because there are a couple sets of rules that use the mean and the standard deviation to tell us how the data in a data set behave. In this video, I'll introduce two of the rules to you and use them to interpret the standard deviation. All right, let's start with the first rule. It's called Chebyshev's theorem, named after that famous Russian statistician Chebyshev. It's got to be one of my favorite all-time names. In fact, I thought of naming my first child Pafnuty Dumbledore. It's got a ring to it, doesn't it? Anyway, in general, here's what Chebyshev's theorem says. It states that at least 1 minus 1 over k squared % of data values in a data set will fall within k standard deviations of the mean. What the heck does that mean? Great question. Well, what it says is if k is equal to 2, then at least 75% of the observations in the data set will fall within 2 standard deviations of the mean. If I change the value of k to 3, then we'll say at least 88.89% of the data values will fall within 3 standard deviations of the mean. Now, a couple things to know about Chebyshev. First, it works for any data set. That's a biggie. Any data set you run into, Chebyshev's theorem is going to work. Second, it's conservative. What do I mean by that? Well, when it says at least 75% of the data will fall within 2 standard deviations of the mean, you got to find this really weird data set so that it's exactly 75%. All other data sets are going to have probably more than 75%, and in some cases, a lot more than 75%. Now, why is that important? We're trying to use these rules, Chebyshev and the next one I'm going to talk about, to determine where most of the data values will fall. Most. What do we mean by most? In statistics, we shoot for most to be around 95%. 90% on the lower end, but I wouldn't go much lower than that. So we want to know where about 90% or more of the data is going to fall. And if you look at Chebyshev, it says at least 75% fall within 2 standard deviations, probably more. But it's a stretch to think that probably more is going to get us up to 90%. So when we talk about Chebyshev's theorem, we're going to say 3 standard deviations is the case. Why 3? At least 88.89%, probably more. Probably 95% of the data fall within 3 standard deviations of the mean, and that's how we're going to interpret it. We're going to say we expect most of our data values to fall within 3 standard deviations of the mean. Now let's consider our second rule, the empirical rule. First thing to note is it only works for mound-shaped symmetric distributions. You know, the kind where most of the data falls closer to the mean, and then you have pretty even or equal tails in either direction. Because we know the data falls closer to the mean when we're using the empirical rule, the Chebyshev percentages change considerably. In fact, the empirical rule states approximately 68% of the data fall within 1 standard deviation of the mean, not most. But listen to this, approximately 95% of the data fall within 2 standard deviations of the mean. That's what we're going to say is most. And then it goes on to say approximately 99.7%, or I'm going to say approximately 100%, or all of the data fall within 3 standard deviations. As we look for our magic 95% number, it leads us to interpret the standard deviation this way for empirical rule situations. We expect most of the data to fall within 2 standard deviations of the mean. We like bumping in the interpretation to use 2 standard deviations instead of 3, as our resulting interval gets narrower, it gets more accurate. When we say we expect most things to fall within 3 and now I can bump it to 2, that's a win. We like the accuracy. Those are the two main rules, Chebyshev and the empirical rule, that are introduced to most introductory statistics classes. The problem I have with that is that when I work with business statistics and business statistics students, a lot of the data we run into is skewed. One of the tails extends further than the other. And if I only give students those two rules, we'd have to go with Chebyshev. We'd have to go with 3, and I don't like that. And so there's another rule I want to talk to you about. I'm going to call this rule the modified empirical rule. And honestly, I thought it was called the modified empirical rule because my mentor many years ago described it that way. When searching for the modified empirical rule and preparing for this video, I couldn't find that terminology anywhere. It just wasn't there. I Google searched and there was nothing. So I called my mentor up and I said, hey, where'd that come from? And he said he read a paper years ago that didn't use that phrase, and he coined the term modified empirical rule. And then he just, through years and years and decades of work, he just noticed it over and over and over again. It works with skewed data. And I said, well, I don't really like going with just that. And he said, well, simulate some data. So that's what I did. What you see are 3 different histograms for simulated data. And when I simulated the data, I tried to make the data a little skewed, then moderately skewed, and then really skewed. I calculated values of the mean and the standard deviation, and I found the percentage of the observations that fell within 2 standard deviations of the mean. And you can see, even with skewed data, and this is what the modified empirical rule tends to say, even with skewed data, most of our data falls within 2 standard deviations of the mean. So whether you're working with symmetric or skewed data, we can still use the 2 standard deviation interpretation. As I said, if you want more information about Chebyshev's theorem or the empirical rule, I've got some videos that you can take a look at. Now, what are you waiting for? It's time to get to work.